Okay, today we're going to cover the Lab5 parts. So for this video, we're just going to create all the parts necessary to build the assembly of the vise that we are covering in Lab5. We'll start with the vise lead screw, which is part 1 in the lab handout. So we'll start with a new file, a new part. For this lab only, we're going to be working in IPS, which is inch, pounds, and second. So you can see there, IPS. So make sure you switch over to IPS if you're working in millimeters, grams. In a second, we'll start with IPS. It's much easier to just switch now. If you start working in millimeters, you're going to have to go back and change every single dimension. So just make sure that you're on IPS to begin with. Then we're going to go ahead and sketch on the front plane. So what we're going to do to create the lead screw is make a revolve. So by now I'm sure you guys are familiar with how to do a revolve and how to use smart dimension and all the other tools necessary to get the sketch. So I'm just going to go through this real quick and show you how I would approach the problem of creating the lead screw. Okay, so that's just a rough outline of what our shape looks like. Right, the lead screw, we can adjust some of this. So it looks roughly like how the lead screw looks in the lab manual. So now we can start dimensioning things. We'll start with the overall length, which is 6.25 inches. There we go. Now, I like to start from the right, which is the smaller of the dimensions. It just makes it easier for me. If you have smaller dimensions, then growing to larger ones. If you do larger to smaller, sometimes they overlap and it becomes a little bit difficult. So I'm going to go ahead and start right on the right here. We know that the, okay, we know that the diameter of the lead screw at this point is 1/2 inch, so 0.5. So we're just going to go ahead and write 0.5 divided by 2, because don't forget we're going to revolve this sketch about this axis right here, which means that all of our dimensions, which should be diameters in the overall part, will be radiuses in our sketch. So we'll just divide everything by 2. Next guy here, this one here should be 0.375 divided by 2. I'm going to go ahead and just do all the radiuses, and then we'll come back and adjust the lengths. So this guy here, it's 0.5 divided by 2. Right, so it should be in line. This guy here, 0.625 divided by 2. Next one here, 0.5 over 2. And our last guy, which is 0.75 over 2. Okay, so now that we have all the radiuses done, we can go and adjust the lengths of each of these sections. So I'll start from left to right this time, and I'm going to put all my length dimensions on the bottom of the sketch so it's more clear. So we'll start here with 0.813. Next guy is 0.250. Next one here, 3.938. And then this section here, if we zoom in, this section right here has no dimension given in the lab manual, but that's okay because we know the overall dimensions and we know these two here, so it'll automatically constrain that. So we'll just finish the last ones. And this guy here, 0.250. Okay, so if we exit dimension, we can take a look, and that should be half of the profile of the lead screw. We'll then select the sketch here in the Feature Manager design tree, and we're going to select Features and then Revolve. And I'm just going to pick the axis of revolution. You can see here it's highlighted. We'll select the center. And that's that. Next thing we're going to do is we're going to make the chamfers on the edges of the lead screw, so we'll go down to fillet, click the drop down, click chamfer, click this edge and this edge, and we will specify those to be, oh, you know what, my mistake, these are fillets, not chamfers, so we'll just click fillet, this edge and this edge, and we'll specify these guys to be 0.0625. Okay, looking good. Next thing we're going to do is to create the hole on the one end of the lead screw. So to do that, we'll look at our front plane, right click, click create sketch, go normal to that sketch, and we'll just zoom in over here since we're working on this side. We're going to create a center circle right in line here with the origin. You can see that blue dashed line highlighting, and then I'm going to dimension that to be 0.344 diameter, and we want this to be 0.406 from the end of the lead screw. Once that's done, I can exit. I'll then select the sketch, go back to features, extruded cut, through all both, so it goes in both directions, and we're going to go ahead and make that cut. There we go. Next thing I'm going to do, we have a small chamfer on the two edges here of this hole that we just created, so we'll go to chamfer, we'll just select the face, it's going to pick both ends there, and then we'll switch to 0.025 and 45 degrees. Whoops, there we go, 45 degrees and 0.025. And if we zoom in, we can see the faces that it's acting on. And then we'll press OK. And that there is the lead screw. Okay, for the next part, we're going to create the vice screw retainer key, part 2 in the lab manual. This one's very simple, so I'm just going to walk through it quickly. Sketch on the top plane and make a circle. Once again, before we start dimensioning, just make sure you're in IPS. So I just switched over there. Okay. Ooh, there we go. Okay. So now we're going to dimension the outer circle to be radius 0.359. So that's 0.359 multiplied by 2 because we want a diameter. So that's that. Then we'll make another circle on the interior here. We'll dimension this guy to be 0.195 multiplied by 2, right? Because we're converting from radius to diameter. Then we're going to make a couple lines. One right at the top of the circle. You'll see here there is a highlight. Let's try this again. You'll see it highlights this point in space here at the top of the circle, which is perfectly in line with the y-axis. Okay, and we'll just drag it along the, we'll drag that along the x-axis to the left. Then we'll do the same thing on the bottom here. Again, same thing, wait till it highlights that point and drag to the left. You can go ahead and close it, won't matter. Now we're going to switch over to trim entities, and we're going to trim the interior circles here and then the exterior of those lines until we get the pin. Then just exit sketch, select the sketch and click extruded boss, and extrude this by 0.124 of an inch, and we'll have that one complete there. Part 3 is the vice collar, so we'll switch to IPS on a new part. Sketch on the top plane, create 2 circles, just like that. Smart dimension the outside to be 0.359 multiplied by 2 because we're converting from radius to diameter. Same thing again here, we're going to have 0.258 multiplied by 2. Then we're going to exit the sketch, make sure the sketch is highlighted, go to features and extrude, and the total extrusion height is going to be 0.813 of an inch. So we'll have something like this. Next, select the front plane, right click and click sketch, select normal 2, and create a center rectangle right at the center line of the top of the collar. We'll specify the width to be 0.094 of an inch and the height from the top of the collar to the bottom of the rectangle to be 0.125 of an inch. There we go. exit sketch, highlight the sketch, select extruded cut through all both, give it a cut, and that's part 3. For part 4, we're going to create the vice screw handle rod. To do this, we'll select the top plane, create a circle, and dimension this as 0.156 multiplied by 2, because we want to convert from radius to diameter. And we'll go ahead and extrude this sketch for a total length of 5.125 of an inch. Okay. Now let's just zoom out here to make sure we can see what we're looking at. Next, we'll go ahead and select the front plane, click sketch, and we'll sketch on this front plane up here at the top. I'm going to create a circle right down the center line. You can see the blue dashed line highlighted. The diameter of this hole is 0.125 of an inch. And we'll do the same thing down here at the bottom. Diameter 0.125 of an inch. And both of these holes are 0.125 of an inch from the end of the rod. 0.125, there we go. Exit sketch, select the sketch, features, extruded cut, through all both, and we have the cuts complete. Let's just rotate here to get a better view. Alright, last thing to do is to chamfer all the edges here of the handle rod. So if we look, we see that all the chamfers are 0.025 of an inch in length at 45 degrees. So we can select 0.025 and 45 degrees, and we'll just select all the edges here. Both sides of the cut, that edge, and both sides of this cut. Then press OK. And that's the vice screw handle rod. Part 5 is the handle pin. To do this, simple sketch on the top plane. We'll specify the radius of the circle, or sorry, the diameter of the circle to be 0.125 of an inch. Then exit, extrude, and we're going to select 0.531 of an inch as the total height. And go ahead and chamfer these corners 45 degrees. And here in our dimension, we're just going to go ahead and select 0.125 minus 0.075. Okay, we're going to bracket that and divide that by 2, and we get 0.0125, of course. But just goes to show you how you can use math functions in the dimension dialog box. And there is the handle pin, so we're just going to go ahead, save that, and move on to the next one. Now this guy's a little bit more confusing, so pay attention to this one, because it can be a little tricky. And this is the handle cylinder. To do this, I'm going to create a new sketch on the top plane. We'll do a circle and dimension this to be 0.75 of an inch. Okay. Then we'll exit this sketch and extrude to be the total height, which is also 0.75. Alright. Then, since we're here, we can go ahead and chamfer these two corners here to end up with a depth of 0.085 at 45 degrees. Okay. So now we can kind of see it starting to take shape. The next thing we're going to do is create a reference geometry. So if we go here under the Features tab, Reference Geometry, we can select Plane. Now for the first reference, I'm going to select the front plane, and we're going to select Parallel. So we know that our reference plane is parallel to the front plane. For our second reference, I'm just going to pick the outside edge of the extrusion, and it's going to automatically select Tangent. So you can see here, it's putting the reference plane right on the edge of that surface and parallel to the front plane. Where you can also flip it to the other direction but we'll just keep it like this for now. Now that we have this plane in space, we're going to select the plane, click sketch, and make a new sketch on the face of the plane. We'll just have a simple circle here. Dimension the diameter of the circle, which is 0.31 of an inch. And we're going to go ahead and put this guy right in the middle, so 0.750 divided by 2. That way it's right in the center. Next, I'm going to go and click extruded cut, and the depth of the cut is 0.434 of an inch, and just go ahead and cut that like that. Then I'm going to right click on the plane and click hide, because we're done with that feature. We won't need to use it any further in this part, so just hide it so it's out of the way. Then go back, click sketch, select the top face, create a new circle in the center. This is going to be for our second cut here, and we're going to specify the diameter is 0.125, so 1/8 of an inch. Then go back to features, extruded cut, and the depth of this cut is 0.375 of an inch. Press OK, and you can see here we get this weird little shape between the two intersecting cuts. You'll know your part is right if it does have these two intersecting cuts exactly like that, and that's because there is some overlap between the top cut and the bottom cut. Okay, next thing we'll do is create a chamfer on the last two edges here of our cuts. So we'll go back to chamfer, and we're just going to select the top and the edge, or sorry, the side cut there. We'll select the two edges and press OK. So now you can see here we have the complete handle cylinder. Part 7 is a 1/4 inch flathead screw. Now this is just a representation of what a screw is. Naturally you would find these in the design library and just copy them over to use in your actual assembly. But in this case we're just going to go ahead and create a plug of what the flathead screw would look like, so it won't have any threads on it. To do this, we'll sketch on the front plane, and we're just going to go ahead and outline what the half profile of the screw looks like, so that we can create a revolve. And then I'll start dimensioning these. So the top radius here is 0.251, and the second radius here 0.25 divided by 2 to convert from radius to diameter, and the bottom. Okay, and now we'll go ahead and adjust our lengths, so we can just pick these 2 points, 0.03, pick these 2 points here, 0.110, and then pick this total length here. Oops. This guy here will be 0.470. Okay. So this is the profile before we revolve it. We'll click feature, revolve, and just select that center line for our axis. Next we'll click the front plane and create a new sketch on the front plane. And then right up here at the top I'm going to create a center rectangle right down the center here. And I'm going to dimension the width, and this is for the cut of the flathead screw, 0.063 of an inch. And I'll select the bottom line and the top line, sorry, the top of the face of the screw, and we're going to select this depth of 0.05 inch. Exit the sketch, click features, click extruded cut, through all both, and there you go. So that's part 7. Part 8 is the vice set screw. So this one is also going to be a revolve. We'll click the front plane and we'll sketch our profile. So roughly it looks something like this. Oops. Okay, we can just fix that like that. And I'll go ahead and dimension all these points here. keep in mind that you're going to have to convert from radius to diameter. Okay, we've got a problem here. We can just drag this out. And that was because I didn't select this line to be perpendicular, but that's okay. We can just quickly adjust that with an angle dimension. So there we go. We have the half profile of the set screw. We'll go back to features and click revolve and click the center line here for our axis. And then, just like in the last part, we're going to have to create a new sketch on the front plane to make the cut for the set screw. We'll zoom in here to the head of the screw, and we'll select a center rectangle in the middle. The width of the cut, 0.031, and height 0.47. Exit, extruded cut through all both, and press OK. Part 9 is the vice jaw plate. So this is the part for your mini design project that you will be asked to modify. So we'll start by a sketch on the front plane, center rectangle, and I'm just going to dimension this to be 2.75 in width and 1.75 in height, which is the 0.75 and 1 found on the right of the drawing given in the lab manual. While I'm still in this sketch, I'm going to go ahead and just create the two mounting holes for the jaw plate. So that's 0.75 and this one too, 0.75. The diameter of the holes is 0.27 of an inch. You'll notice that it says 0.27 through all when referencing the holes, so we know that the complete hole cuts are 0.27 of an inch in diameter, and then the chamfer portion, the countersink portion of the cut is going to be 0.51. So I'll exit the sketch and extrude. Now we're going to extrude to a total depth of 0.188 of an inch, just like that, and then press OK. Next thing I'm going to do is I'm going to select the top plane and create a sketch on the top plane, just like this, and I'm just going to draw a triangle 90 degrees like that. So this is a right angle triangle, you can see here by this icon, with the vertex here directly in line with the origin, which is the middle of our jaw plate. Then I'm going to dimension that vertex to the top of the jaw plate here, and that is 0.094 of an inch. I'm going to dimension this angle here to be 45 degrees, right? Because we want this cut to be right in the center. And then I'm going to go ahead and exit that. Select the same sketch and go extruded cut and do through all both. So now you'll see we have that center line cut there. Okay, next thing I'm going to do is simply chamfer all the edges here of the jaw plate. To do that, I'm going to select them just like this. Okay, and I believe these chamfers are, if we scroll down here, 0.030 at 45 degrees, and we'll just OK that. So the last thing to do is to create the countersink for these holes. To do that, I'm going to do a chamfer, select the two edges, and in the depth I'm just going to write up a little formula here, which is going to be 0.51, which is the radius, sorry, the diameter of the countersink, minus 0.27, which is the diameter of the through hole, and then I'm just going to divide that by 2 to give me the difference between the countersink hole and the through hole. And then we see that it says a 100-degree countersink, which means that just like over here in this cut, we had a 90-degree difference between the two. Right here, we have a 90-degree difference between these two faces. We want to have a 100-degree difference by these two faces, which means that we'll need a chamfer angle of 50, which is half of the total difference between the two faces. So just go ahead like that. Okay. To double check that we got it correct, we can go to evaluate and measure and just select this outer line here, and you'll see diameter 0.51, which we know to be correct. And that's part 9. Part 10 is the vice slide key. So this one's fairly simple and should be trivial for you guys at this point. One thing I did want to mention, when you're watching these videos, it's always a good idea to try and approach the problem, in this case designing all of the components, yourself first. If you are comfortable enough with SolidWorks that you do not need these hand-holding videos to construct the parts, just go ahead and do that. The lab manual is available to you guys, so feel free to just ignore the videos if you can get everything done on your own and without issue. If you're having trouble, of course, watch the videos. They're really useful for those of you who are struggling a little bit. But at this point, simple parts like this slide screw here, you guys should be able to do that on your own. And it's better for you guys to challenge yourselves and to try and create these parts without any instruction, right? One thing you'll note, if ever you have a school project, so say your capstone, and you need to create CAD files just like this, you're going to have to create them yourself. Nobody's going to tell you the right and wrong way to create sketches, right? So it's always good to get in the habit of just looking at the part. How can I create it? Which type of feature should I use? Should it be an extrude or revolve, or whatever the case may be? So test yourself, especially in this lab. Just look at the sketches given to you, the drawings, the engineering drawings, and try to create the parts by yourself. Simple parts like this, right? You should have no problem coming up with the algorithm on how to create this on your own. Right, so you'll see in this case I just did a simple sketch, cut all the features, or outlined all the features, and did the cut everything in one simple sketch just like that. So this is the kind of thing I'm talking about. If you see the sketch and you know that there are simple ways for you to be able to approach this problem, go ahead and do that. If you're having a hard time and you're struggling with how to create the part, then feel free to watch the video. For part 11, the moving jaw of the vise, it's a fairly complex part, so we're going to have to do multiple steps here. The first thing is going to be to create a sketch on the front plane. Now right away, looking at the dimensions given in the lab manual, I can see that a lot of them are going to be mirrored about the center of the jaw. So the first thing I'm going to do is create a construction line, right? So if I just select line, you can do center line or construction line, doesn't matter. So I'll just select for construction here in the options, and I'm just going to select draw this line down the center here. Okay. Now I'll start regular line. So this construction line is going to allow us to mirror the two sides of the sketch. So I'm just going to draw a rough outline here of what the vise jaw looks like, right? Something like this. Now I'm going to go ahead and start to specify these dimensions. And the goal is that since we have so many dimensions here that are duplicated about this center line, just to mirror the sketch, which will make things a lot faster for us. Okay, I want to specify these two lines to be perfectly collinear here if they were to extend, so we'll just set the distance between them to be 0, so it puts them directly in line. And then I want to go ahead and select this width here, this cut, 218, and the height of this cut's going to be 0.187, and this height to be 0.505. Okay, believe that's all of them. Oh, and I guess we have this one here as well. 1.5. Okay, so now we have all of our lines constrained here. You'll notice it's fully defined and they're all black, so I know that there's no unknown dimensions here. Then I'm going to go ahead and select mirror entities. So right up here in the sketch tab, I'll click mirror entities, and I'm just going to select all the lines of the sketch so far, and then it's going to ask me what do you want to mirror about, and I'm going to select that construction line in the center, and you'll see here it copies it all over to the other side. So there's step one. Once we're done creating the sketch, we're going to go ahead and just extrude this guy here to a total depth of 2.5625. Okay. For our next step, we're going to create a second sketch on the side face of the jaw. So what we'll do is we'll just select the right plane here and create a sketch on that right plane. And I'm going to go ahead and go normal to that. So we're going to create a sketch that we want to use to cut the original profile of the jaw. So to do this, we're just going to go ahead and select the bottom left corner here. And I'm just going to roughly outline what that shape should look like. Okay. And again, here to there. And then of course we're going to drag the lines far outside of the body. That way we can cut this whole area here, so it doesn't matter if we overlap into the free space. It doesn't matter. I'm going to sketch fill these two lines here with a radius of 0.125 of an inch, and these two lines like that. Okay, so that's those two complex curves settled there. And then I'm going to create a arc, a center point arc. And we're just going to locate this arc somewhere here. Whoops. Like that. Of course, I want those lines to match up like that, and I can go ahead and just dimension this arc already with a radius of 1.375. There we go. Okay, now we'll start dimensioning from the bottom left here. I just find it easier this way. I'm going to select these two lines here, and I'm going to specify this angle as 74.74. Then I'll go ahead and select the top point of that line and the bottom point, and we'll do a vertical dimension 1.283. Okay. Then I'm going to select this vertical line and the end of the face there, and that is 1 inch. The top line here, 0.581. This far line, 0.312, and the height between that line and this line here is going to be 1. Okay, so once again, we'll see everything, all the lines within the important part of the sketch are all defined. They're all black, right? So there's no guessing. And then these lines out here, they don't matter. They can stay blue because, again, we're cutting into free space, so it doesn't really matter where they are. Then we'll go ahead and do an extruded cut through all both because we're right in the center there. And then we're going to go ahead and cut it just like that. Next up, we're going to create a circle on this face right here. So just rotate around until you can see it. Then click sketch, select the face, and just zoom in like this. Then we're going to create a circle with a center point not on the line but just below, so like that. I'm going to go ahead and dimension that center point, center point to the bottom of the jaw, and that dimension is 2.188, like that. Then I'm going to dimension that point to the right face, and that's going to be 1.374, which of course just puts it in line with the center of the jaw, which is why it lines up directly over the origin. And then we're just going to specify the diameter to be 1.375, like that. We're going to go ahead and exit, then select the sketch, click Feature, Extrude, and instead of doing blind, we're just going to do up to surface, and we're going to select this surface like that. So then you can see here what it's going to do is create this new cylinder which touches the surface, and we can merge result. Of course, you could just do a blind and then just extrude somewhere into the middle of this face, but to show you another tool of SolidWorks, we're just going to go ahead and click up to surface, and you can see there we have that cylinder like that. Then we're going to go ahead and create a new sketch on this face again. We're going to create another circle around the center of that arc. Right, so you can see there I just highlighted the arc, waited for the center to show up, and then selected the center. I'm going to specify the diameter to be 0.75 of an inch. And if we really want to just double check, we can see that this is going to be, we'll measure it rather. We'll just select this line, and we can see here 0.69, which is actually 0.688, so it matches up with the lab manual. Of course, they just round it off. And then if I select measure again, we can see 1.37, which is 1.374, which is exactly what the lab manual says. Okay, we'll select the sketch, exit, go back to features, extruded cut, and we're going to do a blind cut with a depth of 1.188. Okay, so you can see here it's going to cut into the center here of the jaw. So we should end up with something like this. Then we're going to rotate to this back face here, and we're going to create two holes on this face. To create these holes, we'll make a sketch on that face, and we're actually going to use the hole wizard to create those holes. So we're just going to give them 2 points, a point here and a point there. We'll smart dimension these guys to be 0.75 of an inch from the top. Okay, and then from the side here, 0.625, same thing on this side. Okay, then we'll exit the sketch. Under features, we're going to select hole wizard, and then we'll just select the 2 points. Oops. Sorry, we'll specify the type to just be a standard hole. We're going to click positions, and well, it's not working. There we go. Okay, I believe they're selected now. Under the dialog box, we're going to select a 1/4 inch hole under the ANSI inch. So it should say fractional drill sizes, and we'll just select 1/4. Where is it now? Right there, 1/4. So you can see there it's already going to create a preview of what the cuts should look like. Then we're going to scroll down and do end condition blind, and we're going to specify 0.625 of an inch for the depth. If we click custom sizing here under the 1/4 inch hole, we want to specify 0.250 for the width, which of course is a 1/4 inch, and we want to select 90 degrees for the final chamfer. and press OK, and we should have our holes just like that. And the next thing we'll do is just to fillet some of these edges here. So we'll click fillet. We're going to click these lines on this side of the face like this, and we're going to do a 1/8 of an inch, so 0.125 for the radius. Press OK. It should look something like this. This large edge here we're going to select for a fillet, and we'll specify 0.5 of an inch to look something like that. And then the edge of this hole, we'll specify this for a fillet of, sorry, we're going to chamfer this hole, so we'll click chamfer on that edge, and it's going to be 0.03125 and 45 degrees. And then click OK. For the last part of the moving jaw, we're going to create 2 holes on the bottom of the jaw here. So we'll just create a new sketch. Okay, and we're going to put 2 points, and we'll use the hole wizard again. So just put these 2 points arbitrarily in space, and we'll dimension these to be 1.188 from that face there. 1.188. They're going to be 0.625 of an inch from each other, and from this line to there we're going to select 0.186. Okay. Then we'll exit this sketch, go back to features, click hole wizard. We'll select positions, select the face again, and just pick 1 and 2. Then we're going to change our type to a counterboard hole, so it's the first icon here on the top left. We're going to change all the values here. So we're going to select again an ANSI inch, a binding head screw. Our size is going to be number 12, and our fit is normal. Then we're just going to click show custom sizing and change this to 0.1495 inch for the through hole. We're going to select 0.2180 for the counter bore hole, and the counter bore height is going to be 0.375 of an inch. Okay. Oops. Okay, just double check that. 1495, 0.2180, and 0.3750. Okay. And then for our height here, we'll click 0.63 of the inch, and we should have a counter bore hole just like that. For the last part of the lab, we're going to create part 12, which is the vice base, and this will be the final component before the assembly. To do this, we're just going to go ahead and create a sketch on the top plane, and go ahead and create a center rectangle with width 7.25 inch and height 2.75 inch. Then exit and extrude this to a height of 3.3125 inch, like that. Then go ahead and create a new sketch on the top. And I'm just going to go and create a corner rectangle from the top to the bottom. Dimension this side here to be 1.25 inch. and this length here to be 5 inch, so we'll have just a little bit of excess here. Then exit, feature, extruded cut, and we're going to extrude cut this blind into the block by 1.75 inch, like that. Next, we're going to rotate to the short side. So if we look here, this side is a little bit longer, this side is a little bit shorter. We're going to rotate to the short side just like this and create a new sketch on this face here like that. And then for this sketch, we're just going to go ahead and do something like this. Okay. And connect the bottom, of course. Now we'll dimension this. Oops. 1.002. That's going to be a little bit of clearance for the other components when we finally assemble them. 1.063, like that, and the total height will be 1.688. Now we're just going to make sure that everything else lines up, and we want these guys to be in the center here like this, so that's 0.501. Okay, and the total width here on the bottom is going to be 1.252, just like that, and we'll specify this guy to be 1.252 divided by 2. There we go. Exit the sketch and then cut through all to go right through the whole block. So we'll select the sketch, feature, extruded cut, and we'll click through all, make sure it's in the right direction, and press OK. So we should end up with something like this. Then on this same face here, we'll create another sketch. And what we're going to do here is create first a circle right down the center line like that. Then on the far left of the circle, we're just going to select the outer perimeter of this half of the block that we created. We're going to go ahead and trim the bottom half of the circle to end up with a shape like this, and then we can start dimensioning. So our height here, 1.125. The center here, the radius is going to be 0.688, like that. Okay, then we'll exit and go to features, extruded cut, and we can do a number of different cuts. We can just do a blind to go right through, but I'm going to show you guys another one, which is up to next, which is automatically going to look for the next face. Or of course we could do up to vertex and just click this point here, or we could do up to surface and click this face. We could basically pick any one, but the idea is to cut right through, so have fun playing around with the different types of cuts, because they do come in useful. Once we're done with that, we're going to create another sketch on the same surface again, and we're just going to draw a circle right here in the middle, and we'll dimension this circle to be a diameter of 0.625, like that. Exit sketch, extruded cut, and we'll just do up to next on this one. Next, we're going to rotate here to the bottom or the top, it doesn't really matter, but we're going to basically look either top or bottom to this block. So I'm just going to start here from the top, and we need to select this bottom face here as our sketching plane. Okay, and then we'll start on one of the corners. We'll pick this one here. Actually, you know what? It'll be easier to start on the bottom left. And what we're going to do here is create the outline of a rectangle first. Then we're going to go ahead and draw something like this. Okay. Then we'll do a tangent arc like that. And now we can dimension these guys here. So this radius is going to be 1. This height here is going to be 1. The total width 1.5, and the distance between that inner feature to the side there is going to be 0.650. And right here, this height should be 0.641. Okay, so it should look something like this. Then we're just going to go ahead and trim this bottom here, the bottom of the interior feature and the rectangle. So we should have something just like that. Then we're going to go ahead and exit and extrude this guy by 1/2 inch. So extrude will rotate around here to make sure we're going in the right direction. We will flip the direction so it matches the rest of the block, and we're going to pick 0.5 of an inch. So it should look like this. Now we're going to mirror this block to create another block over on this side. So to do that, we'll select Boss Extrude, the last one we just created, and we're going to go ahead and click Mirror under here under the Features tab. Then it's going to ask us a mirror face, and we're going to select the right plane, which is right down the center of our block. So you'll see there it gives you a preview. We'll press OK, and then we're going to do the same thing with this mirror. We will select them and mirror along the front plane. So we should have blocks on either side just like that. So press OK. Now this is only going to work if your original cube was directly centered in the origin. So of course I put my rectangle about the origin, that way my mid planes are all right in the middle, so you can see my front plane and right plane are right down the center of my block, and of course my top plane is right at the bottom. If you do not have your plane set up like this, then you can't do the mirror like that. You're going to have to create a reference plane to be able to flip these components across with the mirror. If you didn't set up your planes, it's probably faster to just recreate that sketch in the 4 corners and then just extrude the sketches by 0.5. Next we will select fillet, and we're going to click all of these edges here, so just the corners of the blocks that we just created. Okay, so you should have all these guys here selected. Under radius, we're going to pick symmetric, of course, and the radius is going to be 0.4 inch, so it should look something like that. Then we're going to go ahead and rotate to the the long side here, and we're going to add a 1/2 inch fillet on this corner, so 0.5, like that. So it should look something like this at this point. Then we're going to go ahead and create the 2 holes on this face, which are going to line up with the jaw plate that we created. So we'll click Sketch, select the face, and we're just going to look right at it. Right, so just click normal 2, and don't mind the other parts that are in the way. Just focus on this back face right here. And to do this, what we'll do is create 2 points in space, one here and one over here. And we're going to go ahead and dimension these guys as 0.625 from the sides. Okay, then we'll just have to rotate around so we can dimension the other dimension here, which is going to be from the point to this bottom line. And we're going to select 1 inch, and same for this guy, OK. Your sketch should look something like this. Press OK and exit sketch. And then we're going to go ahead and do a 1/4 inch hole. So we'll go back to the hole wizard. We're going to select positions and click the face, and then just pick the 2 points. Go back to type and click hole. Don't worry about the dialog box. We're going to select ANSI inch, all drill sizes, and we'll pick a 1/4 inch if we can find it here. And just about there it is. Okay, we're going to select 1/4 inch, then we're going to do an end condition. We don't need to do custom sizing here. We'll do an end condition blind, and it'll be 3/4 of an inch, so that's 0.75, 0.75. And then we'll look through here and we can see the cuts that have been made. Now my sketch here is visible. You can see by the points. I'm just going to right click that and click hide because we no longer need that. Then once we've created those 2 holes, we'll just fillet all the remaining edges. So we'll click fillet here. The radius of the fillet is going to be 0.05, and then we're just going to go ahead and select this entire face. We'll rotate, select this entire face. We'll select this face here, and then we'll select the bottom face as well. So let's just get this guy here and this guy here. Okay, we should have something like that. Let's just double check, make sure we got all of them. We need this guy here as well, and this guy here, and that should be everything. Oh, no, my mistake. We also need this face and this edge here, these interior lines. Same thing on this side. Okay. You'll see that I'm selecting the faces because it is just a little bit faster. If we want all the edges on that face to be selected, then we can just go ahead and select the whole face rather than individually selecting the edges. So here I want all the edges. I'll just click the whole face. Okay, so we rotate around a little bit, just double check that we're not missing any parts. I believe we've got it all. Just double check the manual because there are a lot of fillets here. Yep, looks good. So we'll press OK. And that will be the last part for Lab 5. Just have a look, make sure everything looks right, which it does. And now we can move on to the assembly.